Calculating the enthalpy change of a reaction from experimental data is a really common exam question. So let's look at the best way to tackle it. In this past paper question, we've been asked to calculate the enthalpy change for the reaction between barium hydroxide and nitric acid. So essentially, this is a neutralization reaction. We've been told the volume and the concentration of both the solution of barium hydroxide and that of the nitric acid. These two solutions were added together, the initial temperature and the final temperature. Step 1 is to figure out how much heat has been transferred to the solution. And to do that, we need the formula Q, that's the heat transferred, equals MCAT. M standing for mass of the solution in grams. C is the specific heat capacity of the solution, and delta T is the change in temperature. So let's start with the mass. Well, we know the total volume of the solution because we were told that 30 centimetres cubed of barium hydroxide was added to 45 centimetres cubed of the nitric acid. So the total volume is 75 centimetres cubed. But we also know that the density of water and aqueous solutions is 1 gram per centimetres cubed. So if we know the volume of the solution, we know the mass. 75 centimetres cubed of aqueous solution has a mass of 75 grams. We're going to assume that the specific heat capacity of our solution is the same as that of water, 4.18 joules per Kelvin per gram. Units are important, I'll come back to this in a minute. And the change in temperature is simply the final temperature of the solution, take away the initial temperature, and that came out to be 11.4 degrees. Next up, all we need to do is to plug this information into our calculator, so 75 grams times 4.18 times 11.4. So the heat transferred to the solution was 3,573.9 joules. I know it's joules, not kilojoules, because specific heat capacity units were joules per Kelvin per gram. Now we've been asked to calculate the enthalpy change for this reaction in kilojoules per mole, not joules per 75 grams. So the next step is to calculate the number of moles of one of the reactants. It doesn't matter which reactant we choose. So number of moles of barium hydroxide equals the concentration times the volume. The concentration in the question was given at 1.6 moles per decimetre cubed, and the volume was 30 centimetres cubed. But it needs to be in decimetres, so hence the 30 is divided by 1,000. So the number of moles of barium hydroxide that were neutralised in this reaction, 0.048 moles. So what do we know? Well, we know that 0.048 moles of barium hydroxide transfers 3573.9 joules of heat to our solution. If we want our answer in kilojoules per mole, all we need to do is scale up for 1 mole. So the calculation is 1 divided by 0.048, that's the scaling up, multiplied by the number of joules. And we get 74456.25. Note that I'm not rounding up until I get to the very end. But once again, if we go back, our question asked for our answer in kilojoules per mole, so I need to divide that number by 1,000. However, we're not finished yet, because it's up to us to decide whether this reaction was exothermic or endothermic, and so decide on the sign for the final answer. Well, we know that the temperature rose. Therefore, it's an exothermic reaction, so I need to put a minus in front of my final answer. I'm also going to round up to 3 significant figures because the least precise piece of information that I put into my original calculation was 3 sig fig. So final answer, minus 74.5 kilojoules per mole. You can find the notes and lots of practice questions on this sort of calculation at Crunch Chemistry. Everything you need for A-level.